Good day, grade 8 math science students. Okay, so this will be our fourth module. This will be the topic for our fourth module, and it's all going to be about parallelograms. Okay. So parallelograms, you've already encountered them on our fifth module on the first quarter. So we know a lot about their properties. So later, the properties will be reviewed to you guys, okay, so that we can have a bit of a refresher. Okay, and from there, we're going to start building our proofs or two-column proofs regarding these different parallelograms. Okay, so before that, so let's try to just refresh some pictures, or let's try to view some pictures of parallelograms in the real world. So in the real world, parallelograms are mostly man-made or artificially constructed. So in order for a figure or a quadrilateral to be a parallelogram, so the two sides have to be perfectly parallel, or the two opposite sides must never meet each other. Okay, so that's why it's not common in nature really to find those perfect parallelogram figures, but in nature, in cities, in urban dwellings, we can see a lot of those. We can see a lot of those applications. So for buildings, mostly those are modern-esque buildings, especially this one on a marina. Okay, so this building here is shaped like a parallelogram, and also this one. And you can also find it in floor tilings. Okay, so in floor tilings or in floor patterns, you can also see parallelograms. And a lot of other applications. And in some weird way in nature, so sometimes nature creates these parallelogram like rocks or pebbles or stones. Okay, so they may not be perfect parallelograms, but it's one of the closest that we can get in nature for quadrilateral figures that are shaped like parallelograms. Okay, so here are the properties of the parallelograms. Okay, so we've already reviewed this, and you've already been acquainted to these properties. So let's just try to review or try to retake some of these properties and see how we're going to able to prove them using two-column proofs here for our lesson. So the first one being, okay, so opposite angles of a parallelogram are congruent. Okay, so that's very common. Okay, so that's like a very what do I call this? A known property of a parallelogram. For example, we have here a parallelogram. Okay, let's draw a parallelogram ABCD. Okay, so that means that's opposite sides AB and CD and BC and AD are congruent. Okay, and then the consecutive angles of a parallelogram are supplementary. So that just simply means that if we add the supplementary angles right here, okay, for example, we have here A and B. Okay, so the measurement of angle A and B, if we add them together, supplementary, that means angle A plus angle B is equal to 180 degrees. Okay, so that also goes the same for angle B and angle C and angle D, and angle D and angle A. And also each diagonal of a parallelogram divides the parallelogram into two congruent triangles. Okay, so if we draw this diagonal here, so we have here ABD and CBD are congruent triangles. And also if we draw another diagonal here, we can say that ABC is congruent to CDA. Okay. And also, we have two opposite sides of a parallelogram are congruent, so this follows the first property. And corollary number 1, a diagonal of a parallelogram forms two congruent triangles. Okay, so that's related to number 3. And corollary number 2 for number 4, if two lines are parallel, then all points on one line are equidistant from the other line. Okay, so very, what do you call this, logical or commonsensical. So all of these points or lines are equidistant from the given parallel line. Okay, and the diagonals of a parallelogram bisect each other. So that means when these two diagonals, okay, diagonal BD and diagonal AC intersect, so when they intersect here at this point, okay, let's say that's point X. Okay, so that means BX and XD are congruent, okay, because they have been bisected by this transversal or this diagonal AC Okay, and we also have AX and XC are congruent because they have been bisected by this diagonal right here, diagonal BD. And if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Okay, so we're going to deal with a lot of theorems here in our proofs. Okay, so for the first one, let's prove that the opposite angles of a parallelogram are congruent. Okay, so we have here parallelogram LADY or parallelogram lady with a diagonal LD. Okay, so we want to prove that angle L is congruent to angle D, so that those are the opposite angles. Okay, angle L is congruent to angle D, and angle Y is congruent to angle A. So those are the two angles, two pairs of angles that we have here for our figure. So the general plan is we have to use the ASA postulate and also the angle addition postulate to be able to do this. Okay, so as with all proofs, let's start with a given. Okay, so number one. Okay, so what are given? So parallelogram lady with the diagonal LD. Okay, so we have here a parallelogram. Okay, wait, let's write this nicely. Okay, so we have here parallelogram LADY with a diagonal. What's the diagonal? Diagonal LD. Okay, so let's write that LD. Okay, so that's a given. Parallelogram LADY with a diagonal LD, a given. Okay, and then number two, we can say from our given figure here, okay, let's go back to the figure. Since we have here a parallelogram, then we must have parallel sides, two pairs of parallel sides. So that's LA and YD and LY and AD. Okay, so let's try to copy this figure here so it'll be much easier. So let's copy and let's paste that here, but let's just make it a miniature version. Okay, so we have here, okay, line segments, okay, segments L, A, okay, let's write that neatly here, okay, line segments LA and YD are parallel lines, or parallel segments, and also we have LY and AD are parallel lines or parallel segments. Okay, so that's simply a definition of a parallelogram. Okay, a definition of a parallelogram. Okay. So let's just try to make it more. Okay, so there you go. Okay, for number three, okay, so what we can write for the third statement, since we have here two pairs of parallel lines, we can try to focus or consider line segment LA and YD. So those two segments or those two lines are parallel. So imagine that this diagonal is a transversal. Okay, so if it's a transversal, then we have alternate interior angles here, angle 1 and angle 4 and angle 2 and angle 3. Okay, so therefore we can say that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3 because they are alternate interior angles. Okay, so we can write that angles 1 and 4 are congruent and angles 2 and 3 are also congruent. Okay, that's because they are alternate interior angles. Okay, are congruent. Okay, so for our fourth statement we have here, okay, since we've already established that we have here two congruent angles 1 and 4 and angles 2 and 3, and also we can try to also state here that the diagonal itself, okay, the diagonal itself is equal, of course, to itself. So LD is congruent to LD, and that's because, or the reason for that is the reflexive property of congruence. And on our fifth statement, we can write here that the two triangles are now congruent, triangles LYD and triangle LAD. Okay, so we can write here. Okay, so we can write here that triangles LYD and LAD are congruent. Okay, so the reason for that is of course, ASA, the ASA triangle congruence postulate. Okay, so why the ASA? So we have here angles 1 and angle 4 are congruent. Okay, so let's try to write that. Angles 1 and angle 4 are congruent. Okay, angles 1 and angle 4, so this one and this one is congruent. Okay, so this angle right here, angle 2 and angle 3 are also congruent, and this side itself is congruent to itself. Okay, so that means from ASA, angle, side, angle, two angles and an included side. Therefore, we have this reason or proof right here to show that triangles LYD and LAD are congruent. Okay, and since we've established that these two triangles are congruent, we can write here for our sixth statement that angles Y and A are congruent. So they are congruent simply because of the CP, or the corresponding parts of congruent triangles are congruent. Since we've already seen that these two triangles are congruent, therefore their corresponding sides are also congruent. Okay, so for our seventh statement, we can write here, okay? So we can write here for our seventh statement that the measurement of angles 2 and 3 and angles 1 and 4 are congruent. Okay, so we've already seen that, but we just want to really make it formal. Okay, so the reason for that is, of course, the definition of congruence. Okay, so we are going to need this statement because on statement 8, what we're going to try to state, okay, on statement 8 is that the measure, okay, the measure of angle, okay, so let's just make it complete. Measure of angle 2 plus angle 1 is equal to the measure of angle 3 plus the measure of angle 4. Okay, so how did we come to that conclusion? Okay, so we came to that conclusion through the addition property of equality. Okay, so let's write that. Okay, so addition property of equality. So how was that where did the addition property of equality come from? Since we know that the measure of angle 1 is congruent to the measure of angle 4, therefore we can add the measurement of angle 1 here and also the measurement of angle 1 here. But instead of angle 1, since angle 1 is congruent to angle 4, we're going to write instead the measurement of angle 4. And as we can see here on the figure, the measurement of angle 1 and angle 2, okay, so let's write that. This will be the ninth statement. Okay, so on the figure for our ninth statement, we're going to have the measure of angles 1 and 2 is equal to the measure of angle L, and also the measures of angles 3 and 4 is equal to the measure of angle D. Okay. Okay, so we have here this ninth statement, so it's quite long. Okay, so this is from, okay, so the proof of that is the angle addition postulate. Okay, so let's write that. Okay, angle addition postulate. Okay, so this is for number 9. And then lastly, now we can prove, since we've seen that the measure of angle L is also the same as the measure of angle D, okay, through the angle addition postulate, so we can say that angles L and D are congruent. So the reason for that, since we've already established through angle addition postulate that they're congruent, is definition of congruence.